Okay, so we were looking at acceleration to determine the net force. Okay, so now we're going to use the same kind of data, but we're going to assume that the force is held constant. It's kind of the idea of I'm only so strong and I can only push how much ever hard I can push. My car engine has a maximum value it can push for. There's only so much it can push. So if we hold that force constant, there's no more force available, okay? It's held constant. Then mass and acceleration are opposites of each other, okay? So what's held constant is an important thing to think about as we go through this. But for an inversely proportional, as one goes up, the other one goes down. If you determine which data set has the largest acceleration, you're fine. Okay, so as one goes up, the other one goes down. If you can determine which data set has a larger acceleration, then you know which object has the lower mass. So from graphs and data tables, we can determine if it's accelerating or not. That's kind of the thing. So if we know it's accelerating and the force is held constant, then we know if the acceleration, or if it's accelerating more than something else is accelerating, then that object might have a bigger mass. If it's accelerating less, it might have a lower mass. So let's look at this graph. So this is a position versus time, or a displacement versus time graph. Okay, so we got to check our titles of a graph. We just ran out of space, so it's cut off. Okay, displacement versus time. So this is a curved graph. Is it accelerating or not? It's accelerating. Both of them are accelerating, right? So there's a net force. Which one has a bigger net force? Okay. So if you think about it, accelerating is how fast you're going across the ground over time. So which one's going to go faster across the ground? So let's just pick a time. Let's look at 5 seconds. At 5 seconds, how far is the blue line? The blue line got to 5 meters. Well, how far did the red line get? It got up to probably about 8 meters. Which one's going faster? The red dotted line. Okay? How do you know just by looking without reading the numbers? You see the two curves? You got the two curves. Well, one of them is steeper than the other. That one's going to have the greater acceleration. Okay? So, if the force is the same for both objects, which one of those has the greater mass? Oh, trick question. Because they're opposites of each other, right? Greater acceleration, have the lower mass. Smaller acceleration is going to have a bigger mass. Because I'm pushing as hard as I can. If it's really heavy, can I push it as fast? Can I accelerate it as much? No. If I put an engine in a car, then I put that same engine in a semi-truck, is that semi-truck going to be able to go as fast as the car? No, because the mass is too big. Okay, that's what that means. Okay? So, because they're opposites of each other. Because the force does not change. Okay? Acceleration gets bigger, mass has to be smaller for that force. Okay? And that's basically what I just said. So, got to be careful. This is tricky. You got to look at the title of the graph or your data table. You got to look at, are they saying the force is held constant and you're looking for mass? Or are they saying mass is held constant? Are they looking for force? So be careful because they're different questions. Okay. So go ahead and pause, get that written down. And next one, let's practice this. So we're looking for which data set represents the object with the larger mass. So if we're looking for larger mass, we are looking for the opposite in acceleration. So they're opposites. Mass and acceleration are opposites. They're indirectly proportional. So acceleration goes up, mass goes down. Are we looking for mass going down being small? No. So if mass is big, then we're looking for a small acceleration. So let's find it. What about this object? What's the difference here? 20 minus 18 is, or 18 minus 20 is a negative 2. It's a negative 2. 16 minus 18, negative 2. So notice I'm going bottom minus the top. Bottom minus the top. Okay, so they're all negative 2s. Look at the one on the right here. How is it changing? Oh, did I just make a mistake? Yes, I did. Look at this. Why is what I'm saying wrong or confusing? What's the title of this table? It's a velocity table. So is the velocity increasing, getting bigger, or is it getting smaller? The velocity is getting smaller by how much? -2. Okay. So the velocity is getting smaller. So is it accelerating? Yes, it's accelerating. It's a -2 acceleration. Okay, but look at this one. It's speeding up, velocity, speeding up by 1s. Now, this is different than a displacement graph. If we looked at a displacement table and we saw this, we would say it's not accelerating. But this is not displacement, this is velocity. See how it's increasing? The velocity is increasing, it's accelerating. So both of these, their velocities are changing, so we have a net force. If this said delta D up here, it would be different story, different thing. So you've got to check the titles, check the labels. Velocity is decreasing, velocity is increasing. Now, in math, we generally think of negatives as smaller numbers, but in physics, all the negative means is it's going that way. Positive means it's going that way. So, which one's actually smaller? The second graph has a smaller value, but it's going in a positive direction. Okay, so the second object has a smaller acceleration since the velocity changes by a smaller amount. So this object, assuming that the force does not change, this object is being pushed, has a mass. Did you catch all that? So be really careful. This is not a displacement graph. A displacement graph, these would both be constant velocity. There would be no acceleration, and we probably, let's see, we may not be able to answer this question because the net force would be 0, and the mass could be the same for all we know. Okay? So, very, very interesting. Okay, let's look at this next one. Knowing what you know about velocity graphs, which one is accelerating more? Velocity graphs. So which one's getting faster? Which one's has a bigger, steeper slope? Steeper slope means it's accelerating more, it's going faster than something with a smaller slope for velocity. So which one's not going as fast? Not speeding up that much. It's the red dotted line. So the red dotted line has the lower acceleration. Okay? So the velocity is changing by a smaller amount. This means acceleration. Okay, so this can be really confusing. What's the secret? How do you do this and not make a mistake? You've got to keep in mind, acceleration is a speeding up or a slowing down or a change in direction. If you remember that, then you can start figuring out the next piece, okay? So speeding up, slowing down, or change in direction. So velocity graph, speeding up or slowing down. It's slowing down. It's accelerating. Now we can talk, okay? So that's the key. You got to know, is it speeding up, slowing down? But to know that, you've got to check the titles, okay? Because if this was a displacement graph, then they would both be constant speed. There would be 0 acceleration, so the net force would be 0. Okay, so be real careful what you're looking at. Okay, so we're going to not try to be too tricky. There are going to be some practice problems for you to work through and kind of look at this on the exit check. So please make sure that you go through the exit check and practice these. So first, you're going to look at a graph and table data sets to see when a net force is being applied. So is it accelerating? Is it speeding up? Is it slowing down? Yes, there's acceleration. Yes, there's a net force. Easy. Then we're going to be looking at, okay, which thing is accelerating more? So does it have a accelerating more means a smaller force? Accelerating more means accelerating more means a bigger force if the mass is held constant. Accelerating more means a smaller mass if the force is held constant. Okay, so keep those in mind as you go forward and work through the practice problems. And please make sure you fill out your exit check. Thank you, and I will see you in the next video.